Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if being super open with your research data could actually backfire and hurt scientists instead of helping them? Well, this new paper dives right into that question. So imagine this, there is a big push in science called open science. It is all about sharing everything, your data, your methods, your findings. So everyone can check your work and build on it. It's like saying, here's my recipe, anyone can use it and make it better. This is super important in a field called Metascience, which is basically science about science. Metascientists look at how other research is done, finding patterns, figuring out what works and what doesn't. They want to make science itself better. Now, a recent paper, or rather a preprint called Hellmann et al. 2026 basically said that for Metascience we should never hide who did the original research. No anonymous data. They argue that if we don't know who did the original work, it makes it harder to check their findings to see if the research is solid and to build new studies on it. They want full transparency, meaning you can see exactly which scientist's paper the meta-scientist is looking at and what they found about it. They believe that hiding the original author's name is like putting a barrier up to true scientific progress. But the researchers in this paper we're talking about today, Sassenberg and his team, they say, hold on a minute. They agree that transparency is super important. Absolutely. They think the original studies, the corpus, they call it, and the data from those studies should definitely be shared. But they argue that making that data identifiable, meaning you can see exactly who the original author is, might actually cause harm. They have a few key reasons for this. First, they think Hellmann et al. Have a slightly different understanding of what Metascience is supposed to do and where its limits are. Second, they look at how much people are actually using open science practices right now, and it is not as widespread as one might hope. Third, they're really thinking about how scientists interact with each other, the social side of things. And fourth, they have a more detailed view on the good and bad points of sharing non-anonymous data. So, what do they suggest? Instead of just going all out with non-anonymous data, they say we should always publish the sample of studies, like the original publications, and the data extracted from each publication, but with an anonymized ID. Think of it like giving each paper a secret code name instead of using the author's real name. They believe that publishing non-anonymous data could unfairly hurt the original authors. Let's dig into why they think this. They agree with Hellmann et al. On some basics. Transparency is key. They both agree that search strategies, what studies get included and why, should be clear. And the final collection of papers, the corpus, should be identifiable. The information taken from each study needs to be public. But here is where they really diverge how they see Metascience. Hellmann et al. Seem to view Metascience as a kind of quality control department for science. They see it as finding flaws, errors, and things that are wrong. They quote Metascience as analyzing research artifacts to see how complete pre-registrations are, how often key reporting elements are missing, or how frequently analytic flexibility appears. Sassenberg and his team say that is a bit too simplistic and can be misleading. They don't believe there is always a clear right or wrong way to do science, especially when it comes to many practices. Sure, there are obvious no-nos like faking data, but for many other things, like deciding to remove a few unusual data points or changing your analysis plan slightly, it depends on the situation and the researcher's intent. Instead, they see metascience as more about describing how science is actually done. It is about collecting data on scientific practices, finding patterns, understanding things like why some studies are reproducible and others aren't, and building theories about how science works. It's like taking a bird's eye view, not a judge's bench. They argue that if there aren't clear, agreed upon norms for a practice, then the metascientist evaluation is more of a subjective judgment. Sharing non-anonymous data in such cases might just be sharing one person's opinion about another's work, potentially unfairly labeling it as problematic. Another big issue is accuracy. When humans code this data, like reading through papers and deciding if something fits a certain category, mistakes happen. Even if coders agree most of the time, there is still a percentage of errors. If that miscoded data is linked publicly to a specific author, that author could be wrongly flagged as having done something wrong, which can have serious consequences for their reputation. They also bring up the practice what you preach argument. Hellmann et al. Say metascientists should model good open science. But Sassenberg's team points out that open science isn't yet the universal standard. Many researchers are trying to be open, but they might not be perfect at it yet. They cite studies showing that even in psychology, only about 30% of papers share their data openly, and even fewer have pre-registrations. And the quality of what is shared often just meets basic standards, not ideal ones. If these researchers who are trying their best to be open suddenly have their less than perfect implementations publicly detailed and linked to their names, it could discourage them and others from participating in open science at all. It could make the cost of being open seem too high. Then there is the social aspect, how scientists relate to each other. They discuss how changes in procedures or technology always lead to social responses. Elson et al. Dismiss fears about being named and shamed, suggesting scientists should just get used to transparency. But Sassenberg's team argues that the fear of public criticism, ridicule, or being put on the spot is very real. This isn't some abstract idea, it has damaged individual careers and entire fields. They note that a lot of this harsh criticism happens not in formal journals, but on social media in informal settings, or through gossip. And science, especially psychology, is still far from having a healthy error culture where mistakes are seen as learning opportunities rather than career-ending events. They emphasize that the culture we need should encourage openness, not threaten people for not being perfect at it. Forcing non-anonymous data sharing could actually make scientists less likely to adopt open science practices for fear of being criticized. Now, let's talk about what non-anonymous data actually adds. Elson et al. Suggested it is crucial for validating coding schemes, meaning checking if the way the metascientist coded the data is accurate. Sassenberg's team argues this isn't really a big problem. By sharing the list of studies, the coding rules, and how much the coders agreed, others can recode parts of the data or a new sample and check the results. This can be done without knowing who the original authors were. They also argue that expanding the study, like adding new types of data points, is rarely done and, if needed, can be done in collaboration with the original authors. And for training purposes, using generic examples is often better than using real, potentially flawed studies. So, what is the conclusion? Sassenberg and his colleagues think that while sharing the original studies and the extracted data is vital for reproducibility and further research, making the original author's identity public isn't always necessary, appropriate, or helpful. They suggest that anonymous paper IDs are a better option, especially when there is a risk of harming authors. If metascientists really want to share non-anonymous data for further research, they should do so in a secure repository with restricted access, like scientific use files. These files could have agreements that prevent the reuse of data to identify original authors. In an ideal world, yes, sharing everything openly would be great because transparency is essential. But they believe that until science develops a stronger error culture that doesn't make well-intentioned researchers anxious about their reputation and career, especially early career ones, public data sharing without revealing author identities, along with restricted access for non-anonymous data, is the best approach. So, what is my take on this? I think Sassenberg and his team make a really important point about the human element in science. Openness is great, but it needs to be balanced with empathy and an understanding of the current realities of scientific careers and the social dynamics within academia. Forcing complete transparency without considering the potential negative consequences could, paradoxically, slow down the very progress it aims to achieve. The idea of anonymized IDs is a smart compromise, allowing for rigorous checks and future research without exposing individual scientists to unfair criticism or reputational damage, especially when the rules are still being debated and solidified. I love that they're not saying never share non-anonymous data, but rather consider it very carefully and perhaps restrict its access. This acknowledges that sometimes for specific types of research or collaboration, it might be necessary. But it shouldn't be the default setting that could harm individuals. It really highlights that science isn't just about data and methods, it is about people, and creating a supportive, rather than a punitive environment for scientific exploration is crucial for long-term innovation and discovery. Future research could explore ways to better facilitate collaboration on non-anonymous data when truly necessary, and perhaps even study the impact of anonymized versus non-anonymized metascience data on the scientific community's perception and adoption of open science. What do you think about this? Should metascience data always be fully identifiable, or is the anonymized ID approach a better way forward for now? Let me know your thoughts in the comments below. Don't forget to like this video if you found it helpful, subscribe for more science breakdowns, and hit that notification bell so you don't miss out on our next Mind Lab episode. Thanks for watching, and I'll see you in the next one.